Phil. I want to thank you very much for watching my little bit of an introduction video. This is all about an introduction to HHO or hydrogen hydroxide, dihydrogen monoxide, Brown's gas, whatever else people want to call it. In effect, it is a gas produced by electrolysis of water, so it's 2 parts hydrogen, 1 part oxygen. It's burned in the same proportions as it is created, so it is 2-to-1 mix. There are loads of videos, some being quite extreme, some being very bland, some with an agenda, some trying to sell stuff. This is more just as an introduction. What is it? Well, anybody who's ever seen the Hindenburg disaster will know that hydrogen burns an awful lot. Let me show you something. So, as we've seen, hydrogen can be quite a volatile substance. A little interesting diversion, and sorry, a lot of my videos will have diversions in them, or digressions, should I say. Mythbusters did an episode where they looked at the Hindenburg, and because of this aluminium doping that was put on the outside of the fabric for the shell, they said that would have acted like thermite and made it a lot worse. You may see in a little bit that might not be entirely true. But anyhow, so back to the topic in hand. So what we have here is a couple of little things. One is this hydrogen hydroxide generator, or HHO generator. I bought that in, and this is not a review of that unit. It's a very nice little unit. Turn it on, 20 seconds later you've got gas. It gives me a nice benchmark. It gives me something to compare my own things with, and we'll investigate what we can do with this further on in the series. So I'll just show you a little bit of video of my HHO generator. So we've got the HHO generator as well. Now, for some of my tests, I want to make sure that when I am running the flame over something or trying to cook something, as we will be doing later in the series, I need to know that I can have my torch position and my torch speed actually being consistent through the tests. So I've put together a real little Arduino rig just to give me some kind of control over my experiments. Again, it gives me a baseline to do further tests, not based in any comparison on gut feeling, but by measurable, repeatable, accurate data. And the data sets that we are going to be playing with will be increasing as we go through more and more experiments over the film series. So let me just show you my little rig now that I'm going to use for controlling my torch. So this is my little control rig, little Arduino Mega. I'm only using one of the stepper boards, but they're there anyway. Power supply, on-off switch, display and keypad for when we get to there, and a little stepper axis and a webcam. And this is the torch itself. So There are several videos where people are showing what they can cut with various HHO torches. And I kind of don't really want to go over that because it's already out there. But at the same time, for anybody who's seen this for the first time or has not actually realised the significance, I think, of some of what is being seen, it's worth just doing a couple of, well, one little cutting experiment that you'll see all over. Not advertising, it just happened to be an aluminium soft drinks can that was lying around. Let me just put this little bit of video on for you. And I'll give a little bit of a voiceover while that's happening, and then we'll discuss some of the more interesting parts of this. So here we see just how fast the HHO flame will cut through aluminium. And initially it looks quite impressive, but it gets a bit strange after this. So having seen how quick that flame would cut through an aluminium can, you would expect a nice, steady, slow travel to cut through this aluminium disc or this aluminium plate as though it wasn't even there. And it doesn't. It doesn't seem to have any of the same cutting characteristics as we had on the can experiment. So that starts opening up a series of questions. So the next little experiment to try and find out a little bit more of why we had such a poor show with that aluminium is to try and prove that it was not just a case of the aluminium dissipating the heat too quickly, because it is only a small torch. So what we have here now is a stainless steel piece, which is quite a lot bigger, so therefore got in effect more cooling capability. Now let me just speed this up slightly. So now we are just beginning to heat up the stainless steel. Now, one of the things that we do know is stainless steel has got a far higher melting point than aluminium. So if we couldn't get that aluminium to do anything, we would expect very little result on the stainless. But lo and behold, as we start getting in there, we start seeing that we have got the capability of making that steel glow certainly orange hot. And so we've got the ability to put the heat into that part of the work. And so you would assume with that heat of flame that that aluminium again would have stood no chance. And it gets a little stranger. Well, we've kind of reached the end of our first attempt at doing a YouTube video per se. As you can see, there's some very interesting characteristics with this flame. The thin aluminium it vaporised, the thicker aluminium it didn't even touch. The stainless steel was glowing white orange hot. The ceramic was white hot. So one of the interesting things I think this little video shows is the fact that the flame itself is very reactive depending on what it is being pointed at. The other thing is why do we have this difference in reactants? And this will be the subject of a future video. Is it potentially that the surface is getting oxidised? So, in the case of the aluminium can, there was a lack and it prevented the oxidation, and therefore the flame cut it simply. The other potential is that the pressure behind the flame is not enough to disrupt the surface of the pool of molten metal, and therefore we are limiting the amount of a thermochemical reaction that can go on. So we're going to look into greater depth in upcoming videos. The other thing that we're going to be looking at as well is how we can increase the pressure of my hydrogen generation system, how different pulse forms, pulse shapes will make a difference to our generation. We're also going to do another little experiment, which again will be dependent on the higher production capacity for HHO. Let me just show you another little video before I sign off for today.
This is a little two-stroke engine, little 49C two-stroke engine, which I'm going to be running on HHO. This is where my control panel will be situated on this, which will give us the ability to check speed. We're going to have a dyno so we can check torque, we can check power, consumption and pressures. This is another little generator unit which is waiting to be compared with the one that's inside the current machine, and that will be compared with my own development later on.
Some of the potential uses, some of the drawbacks, quite a bit on how to harness the gas and how to create it more and more efficiently with comparisons. Obviously, we're going to be using a lot of data acquisition. We'll be using a lot of Arduinos, I guess, to do this, just so that we can actually create live data streams for the experiments. And all in all, I'd like to see exactly just how far we can take this technology. So once again, thank you very much for listening. I do appreciate your time, and I hope you found this enjoyable. Thank you.